Good evening, everybody, and welcome to ML Ticket. And we are continuing with our project. We have come a long way, I would say. And in the previous session, we saw some of the metrics that we could use to evaluate our model. And I told you about the three types of accuracy scores that people generally consider. That is the training accuracy, testing accuracy, and the optimal algorithm to use. That is the cross validation feature that is given to us by scikit-learn, and how to use it. We also discussed a little bit about that also. Okay, so let me just continue and present my screen, and let's get started. Okay, so let me just let's just have a look on what did we do last. So we discussed this cross validation score, to how to use this cross val score. Let me get to the point. I use this first. Okay, yeah, this how to use this cross val score, and what are the techniques that we could use and all. We learned many things, but now, as I mentioned yesterday also, we saw this entire cross validation over a entire new data set known as iris. And I said, Jay, I was doing that so that you can understand better, and since it's a very small data set, be able to uh, you will be able to understand it in a comprehensive way, rather than if you directly dive into it. Okay, so today, as I promised, I'll be using this cross validation over our current data set that we are currently using. Um, so I gave you we dedicated an entire session just for this cross validation, and we are actually going to dedicate the half of our today's session to this cross validation. As you can see that this thing is very important. Very important if you think of it. Okay. Okay. So let me just start by creating a function, helper function, I would say, which we will use as we go. I don't want to print those scores, standard deviation, then mean separately every time. So let me just create a function which will get scores inside it, and it will just print the scores. This is just a helper function that I'm using. Okay, so you don't need to worry much about this. Okay, scores and means are enough, I guess. Oh, sorry, you don't have this right now. Uh, okay, so what happened? So only this thing. I'm just defining a helper function. Now we start with our cross validation. Okay, so we already have our cross validation, and if you remember that under, let me get back to it. If you remember that under tree reg, yeah, this tree reg variable, we have our decision tree regressor, and we have used a random state of 42. Okay, so first we want to, what do you say, first we want to see the cross validation over this particular regressor. Okay, nothing much. Okay, so let's see what value does it give. But it is to be remembered that we are not, as I said, J, in the previous, when we are using cross validation, we use the scoring technique which is known as accuracy. Okay, so and I also mentioned that accuracy is only meant for, is better for classification problems. Okay, so we can use accuracy. There's not a problem. But since we are only using RMSE scores, that is root mean squared error scores, so that's why we are going to use that metric only. So that at least for our original project, the metric in which we are evaluating remains constant. Okay, so we have already have cross validation, I guess. So let me just get scores, cross val score. We have to pass the model. We have to pass housing prepared. Oh, there are so many variables right now. And housing labels, I guess. Housing labels. And we are going to use a scoring technique. Sorry, it is known as negative mean square error. I'm going to discuss a little bit about this. Don't you worry. And of course, the number of folds we want 10. As we discussed yesterday, that experimentally it is found that the k, when in k fold cross validation, the value of k is as if we put the value of k as 10, it gives the optimal output. So why we are using this scoring equals to negative mean square error? We are not, why we are not using a mean square error? Okay, so first things first, you have to understand this when we are using cross validation, right? Yeah, and we are trying to get mean square error. It by default, it gives a negative mean square error. So that we are placing a negative in front of another negative. So the negative crosses out and it becomes plus. Okay, so it's mean square error only, but by default cross validation provides you with negative mean square error. That's why we use the scoring technique of negative mean square error. But at the end of the day, we want root mean square error, right? So that's why we are going to say tree RMSE scores equals np dot sqrt, that is square root of negative scores. Okay, so since we are we are getting our output in a negative format, that's why I am applying a negative, so that the negative cancels out. So by default, by the scoring techniques, as I said, J, it is negative mean square error, so it only output negative mean square error. So to convert it into a positive value, I have to place a minus in front of that. Okay, so let me just run this cell and hope it runs fine. Okay, it took a while, but it's okay. And now we are going to use that helper function of ours, that is uh, this scores, and we will see the scores in a comprehensive way, so that we can have a good look over the score. So the value that we want, that is 3 RMSC scores. Let's see what happens. Okay, so we now have 10 individual RMSC score, and if you remember that diagram of yes from the previous session, this diagram, to be honest, you should have a clear understanding that how this cross validation works. So I don't not explaining how the cross validation works and why we are getting 10 values here. And the first thing that I want to look at is the scores, and the next thing that I wanted is the mean, as we have discussed in the cross validation K4 cross validation algorithm, to use the average of the testing accuracy. So we have our 10 testing accuracies, and now we want the average. That's why we kind of go for the mean. Okay, so let me just do the same thing. Let me just do the exact same thing. But I want this for the linear regression. We have a linear regression, right? Linear regression model, and I don't want that. I want to evaluate the linear regression for this particular. Right. So let me just change the names of the variable and make sure that everything is fine. Okay, so okay, not 3 RMSE, it should be lin RMSE SQRT squares lin scores, and let me just display it in the same cell. I don't want to do another cell, and but we want lin here. Okay, so let's see if it runs fine. Oh yes, it runs fine. Okay, now you can see clearly. At first, we had a little bit of problem understanding the which model to choose, if we have to only choose between decision tree and linear regression. But now we have a clear idea. Now, if you can see, you can clearly understand that the mean in decision tree is larger than the mean in linear regression. As I said, the linear regression is a very if you remember that the linear regression is a very simple algorithm. That is the most simplest algorithm in machine learning, and this decision tree is much complicated than that. Of course, if you don't remember decision tree, let me just get to the decision tree looks a little bit like this. It takes up all the decisions, it branches out and all. Okay, so basically, as we have seen that our linear regression model is underfitting. If you don't remember that, I would like you to go to back to the sessions that we have had um, previously, and we have talked about this in a very extensive manner. So I'm not going to re-explain that. It will take up more time then. So the linear regression model is an underfitting model, right? We saw that it was underfitting, and what model that tree model, that is the decision tree model, as we have seen. If I can pull out that thing, yes, yeah, you make yes the here's the tree RMSE score. Okay, and we saw that it is getting a RMSE score of 0.0. That is 100%. It is making 100% good effort to get the values. But as I said, that this is not possible, and the data is overfitting. So we can say, so to sum that all up, that is our linear model is underfitting, and our decision tree model is overfitting. But but our tree model is so badly overfitting that our underfitted linear regression model is works a little bit better than our decision tree model. You may have this could be a little bit off for you to understand, as you can that you can ask now, you can directly ask, wait a second, you said the linear regression is the most simplest algorithm in machine learning, and now and decision tree is much more complex than machine learning. Okay, so basically underfitting means it is taking up less, it is taking up less features, is picking up on less features, that I can understand. And the decision tree is picking is overgeneralizing. Okay, that I also can understand. That is the first linear regression model is underfitting, and the decision tree model is overfitting. Okay, we can understand that, but but as we can see that the aptitude, the potentiality of the underfitting model is less than that of the overfitting model. The decision tree model is so badly overfitting that the linear regression model is better than that. It is a very most of the cases where that you will be coming across, this is not the way around. The reverse should have happened, like the decision tree should have it should have worked a little bit better than our linear regression, because as it picks up on very complex data, it is a very complex algorithm if you can dig into it. But it is so badly overfitting right now that our linear regression model is better than that. So basically, we can this is a very good instance that we can understand the there are sometimes linear, sometimes simple things in life makes more sense. The more the complexity increases, the more the problems you have. Sometimes you just need to keep things simple. As it is we know this thing in our life, we have some of us also apply these things in our life, but it is also applicable to machine learning aspects. So you should always link up real life with machine learning so that you can understand it better. Whenever you want to understand some subjects better, it is better to link up your real life with it. Okay, so what is the solution? So I don't want neither either of this. Okay, so let's go with another algorithm. We talked about it. That is the random forest algorithm. That is, if you take a bunch of decision trees and put them together, it that type of algorithm is known. That same thing. This same thing is known as random forest. And then under random forest, there are multiple decision trees. If you understand decision trees. You understand random forest. This is that simple. Random forest contains many decision trees under it, not one decision tree, many. So let's code that up, and let's see use our all the things that we have learned and understand how well it is working or bad it is working, and let's see what happens. So let me just Okay, we have two classifiers, by the way. We have a random forest classifier that is used for classification problem, and since it's a regression problem, we want random forest regressor. I guess that is very evident from the name only, so I don't need to explain that explicitly. Okay, so I am going to pass in estimators. So basically, n estimators is generally I can in the very simplest term is the what do you say, the depth of the tree. Okay, so now you may ask, what is the depth of the tree? Now if you don't know if you don't know graph theory and all, it is a little bit problem for me to make you understand what is the depth of the tree. So I'm just going to skip over this particular topic, because if you don't know graph theory, it is a little bit it will be very problematic for me to make you understand this particular thing. So I would like you to just read through some articles on this. As you can see that when we get into this um, machine learning phase, machine learning algorithm phase, it is not if you can know, you cannot know everything inside it. Okay, so you have to keep updating. Okay, so these libraries are key updating even when we are talking right now. Okay, so every day something new is coming, so it is almost impossible for you to understand and get everything out of it. So but the just get the most general things that we use. Okay, they're general general terms that we use, get familiarized with them. So that's all. You don't have to by heart anything inside machine learning. Everything is on the internet. I would say in the internet, I guess. I don't understand sometimes. Correct me if my preposition was wrong. Okay, so we are fitting the data. Let's see what happens. Random forest takes a fairly a little bit more time to train, but as we have said, 20,640 points are way small data set. Yeah, okay, so it does not matter. So you cannot see that time explicitly, but it takes a little bit more than decision tree or linear regression. Linear regression is just like within a second. Okay, so let's see. Uh, okay, I want to. Okay, we have have that right. Yeah, I want to just copy this cell. Okay, copying code is the best thing to do, to be honest. Code reusability, kind of. Okay, so let me just change these variables. Forest, also forest. I think it's forest, right? Forest, and forest. Hope everything is fine. Let me just go through it once more time. Okay. Mm, okay. This one, forest. Okay. Fingers crossed. As you can see, as I said, it takes a little bit more time. Okay, we have it. So we get a mean of 50 to 100, which is better than linear regression as well. So as we saw, when we are going, we have completed training three models on our data set, right? We trained a linear regression model, a decision tree model, and a random forest model. And among this, the random forest model regressor is working way better than linear regression, or what is that? Linear regression or decision tree. So now, to be honest, this is the point where you should end. Okay, this is the point where you should end. So you can just predict values now. You can just start putting in random values and inputs, and it will predict the output. How will you do that? Yeah, I have actually shown you that thing. So let me just get back to that code and you will understand. Yeah, this thing exactly. Okay, this thing. Just do a dot predict and pass the values, and it will pass the data set or the numpy array. I guess we have to pass a numpy array here. Pass the numpy array, and it will generate it in no time. And if you want to transform that value, you have to transform that value at some point. So you can just use the full pipeline and dot transform function to transform your data, and you can just use that data to predict the values. So it is now that simple. So we have to be honest, we have officially we have completed our sessions on machine learning because you have completed ML algorithms. But I want to speak a little bit more on a few things, and we are going to do a little bit of something. And let me just write the code first, and then I'll explain it. Okay. Okay, just let me just go through it once. As we can see, if you remember in the last session, we did something like, yeah, this one. We wanted a optimal value of k in, and we have to pass that value in neighbors. But we want the optimal value of the n neighbors. Okay, inside the k neighbors classifier. Okay, and we don't know what is the optimal value. So we decided upon a range that 1 to 30. What is the optimal value in 1 to 30 which can be chosen as the n neighbors attribute, so that we get a greater accuracy. So what we did, we used the cross validation score thing, and brute forced with all our values, and drew a plot, and we saw that in 20 it is reaching the peak point. You can say, okay, why I'm not picking up 17 or 14, something like that, because whenever you're doing this, it's better to take the value which is close to the end range that you have provided. Since 20 is closer to 30, that's why I've chosen 20. I could have chose other values, but this is the protocol that you should maintain. So this is one way to fine tune your model. As we see, previously we are getting a accuracy score of 96%, and after we did this, we got a accuracy score of 98%. This 2% is very essential, very crucial sometimes. Maybe we had a big jump here because we jumped from 96 to 98. This is a big jump, but sometimes you get a very small jump, like zero. There's an increase in percentage with 0.05. With it increases the percentage by 0.05, but that also counts, right? So you can apply so many attributes. I only tested out one attribute, and you can brute force every attribute that you want. Okay, so there is a this is a good method, to be honest. But to be honest, sklearn has already provided us with something which do this thing on without brute forcing the stuff through. Though I think it brute forces only because there is no other way, but still it does this thing in a very efficient manner, and you don't need to hard code these things. But to be honest, if you are using, or if you are only fine tuning a single attribute inside the classifier or regressor model that you are using, then I would suggest that go for cross validation. It is faster. Okay, it makes more sense. But if you have multiple attributes to work, like you are only passing one attribute over here, right? Or that is n neighbors. But suppose there are multiple attributes. Okay, if you look into the official documentation of n neighbors classifiers in scikit-learn, you will see there are multiple parameters that you can pass. Okay, and what if you wanted to fine tune all those parameters, every parameter? You have gone through every algorithm, all the parameters, and you have a clear knowledge of what every parameter does, and you want to fine tune every parameter. You don't want to leave anything on default. Then what you can do, you can, okay, I'm again telling you this thing. I also mentioned this thing yesterday also, that whatever we are talking from the previous session is a little bit intermediate stuff. Okay, these are not some beginner thing. I would not suggest you to go for this technique that I am right now. I am going to show you, because it is very important for you to know that this thing exists inside sklearn or machine learning. Okay, because when you jump from beginner to intermediate, you should be using this technique. Okay, so but as a beginner, you should just stop right here. You can just stop right here where I have stopped right now. But after this, I am going to show you another fine tuning method that will be a little bit helpful. But to be honest, you don't need to do this when you are doing your project. Okay, as a beginner, you can just stop here. Stop here. But to be honest, my Responsibility is to make you go through every possible things that is present in machine learning, and this is a quite important and interesting thing that people tend to overlook. So what is this thing? This is known as a grid search CV. Okay, so let me just uh, write the code, and then I'll be explaining. Then I'll be explaining it entirely. So basically, we have to create a parameter list. Okay, parameter list which contains dictionaries. Okay, so and inside the dictionaries we have to name those attributes that we want to tweak. So suppose we have n estimators. I guess we have to spell it correctly, by the way. And I want to pass a list which will contain all the values that we want to experiment with. Let's go with 3, 10, and 30. Okay, and let's add another parameter. Okay, inside another, sorry, inside another dictionary. This is known as max features. Now you may ask, I don't know this kind of what this actual attributes does actually. To be honest, for that you need to, to be honest, for that you need to go through the documentation and read the machine learning algorithms on your own. But right now, you just understand this thing that these are some of the parameters, these are some of the attributes of the I think random for yes, we are using random forest, right? Random forest regressor, and we are going to use this things. Okay, so max features we want to pass to 4, 6, 8. Mane, it will make all the possible combination between all the values that we are passing. Like it will try with 3, it will choose 3, and it will try with 2, 4, 6, 8. Then it will pick 10. It will also try with 2, 4, 6, 8. Then it will pick 30 and will try with 2, 4, 6, 8. And this is how it is going to happen. Okay, and it will generate the accuracy score each time, and each time the accuracy score, and it will at the end of the result it will return the best combination of combination of estimators that we can use and pass through our model to get a better accuracy score. Okay, so let's get another attribute that is known as bootstrap. I don't want to explain these things. What these things does and all, because to be honest, that this is a little bit intermediate level. So you just need to understand these things. Oh, sorry, I know I made a mistake. I guess this has to be under one roof. Yeah, yeah. We want to explore two sets of estimators. That is one set contains n estimators and max features with corresponding values. Another contains bootstrap, n estimators, and max features, right? So I can just copy this thing, I guess. Okay, but we want to change those values, so just randomly pick out some of the values like 2, I think 3, and 4. Okay, randomly chosen values. Now we want to create our model. We have our model ready, but let me just create the model once again. Yes, random forest regressor. We want a random state of 42. And now we want to apply the grid search thing. Grid, sorry, grid search, and you don't need to understand the code right now. Okay, that is not the purpose. I just want to show you how this thing particular works. It takes a little bit of time, so let's just wait. As I said, random forest regressor takes a little bit of time. It takes up a lot of computations. To be honest, if you run this thing on your CPU, it will run a little bit slow. I am still now it is running this thing on CPU. But if you are using Jupyter Notebook and use this particular thing, and use your GPU to run this these things, machine learning things, so it will be running a little bit more faster. So we have our model ready. So now how do we see the best estimator? It is better to use this thing. There is grid. Okay, let me just zoom in. Grid search dot best estimator. No, not estimator. Let's try for params first. Okay, best params. What are the best parameters that we can pass? That is max features equals to 8 and estimators equals to 30. Okay, so if we pass this parameter, then we will get the best accuracy score. And if you want to get the entire thing, we cannot just copy paste this thing, but if we just write grid search dot best estimator and run this cell, we will get the entire thing as output, entire class as the output. Just we can just copy this thing, just try it out once again. Okay, where did we create? Okay, yeah, this one, right? I want to copy this thing. um, let's paste it. uh, let's change the values. Okay, all right, wait. Okay, so first we need to copy this. Okay, So let me just change the names, and rather than using this estimator, we will be using this one. Let me just get if I'm using random state for, yeah, we are using random state 42. Okay, so copy, paste. Okay, and one dot fit. Okay, one one housing levels code CV10. It's all right. Scores one, forest course one. I can just leave it like this, right? But I don't want to overlap those values right now. I think it's fine. Let's see. Fingers crossed if we get an error. That could be a typo because we have just changed the names of the variables. Okay, so let's just wait a little bit. It will be taking up that, creating that regressor. It will be using cross validation. In cross validation, it will is going for stratified sampling. Oh, now look at the mean. If you previously looked at the mean, it is like 5200 52,583, and now it's like 49,413. It has reduced, not by very much. It has not reduced a little a lot, but to be honest, this is better than that one, right? So this is how you fine tune your model. So grid search CV. Another thing is that normalized search CV, I guess. You can use these things to fine tune your model. But to be honest, this fine tuning your model is an intermediate thing to do, to understand. Other than that, you should just understand and stop till this point. I would suggest you to do these things using cross validation only. Okay, though I know that it takes a lot of computation power, it takes a lot of time to do that. Okay, but I will suggest to go for cross validation so that you get a strong understanding with the cross validation. And now, and after you get the heck of it, you can easily move to grid search CV. There are multiple ways to do this. There are multiple methods. This is one of those methods. I have shown you two methods to fine tune your model. That is, one is that cross validation, and another one is grid search CV. There are numerous other ways to do, to fine tune your model. So I'm not going to discuss about that. You was fine tuning your model is a topic which is covered in intermediate level, not in the beginner level. Okay, so we have officially we have completed our uh, completed our machine learning sessions, and hope that you people enjoyed to go hope that you people enjoyed uh, through this journey that we had learned so many things, man, from the scratch, that the point from the point we have never heard of a supervised learning, from to the point when we have solved that problem, and we have created few models and evaluated methods to understand how to fine tune that model, how to visualize the data. So many things that we have learned. It has been a wonderful journey, and to be honest, you guys have been phenomenal uh, ever since. So thank you for coming taking this session with me. And of course, we have 2 days, another 2 days left with us, 2 or 3 days left till we are complete. So for that, I'll be just going through the entire project one more time in a very slow paced manner, because so we have learned so many things. Sometimes it could be a little bit confusing for you to get everything inside your head. So I'm going to go do a revisit of all the code that we have written, all the concept that we have covered, all everything that we have seen on the screen. We are going to get a quick revisit of that from the next sessions, so that by the end of these sessions, you will understand each line that I have written in a very extensive manner. And as I've been saying from the first session, that code is not important. Do not trust somebody's code, not even my code. I don't want you to trust my code. Just write the code, because as I am writing this, it may, after 3 months, some kind of update may happen, and scikit-learn may place this model under that class and all. All these things, sometimes scikit-learn removes an entire thing, like it has removed the imputer class and has replaced it with simple imputer class. Okay, so these things sometimes happen. So do not trust the code, but if you have got the knowledge, if you get hold of the uh, uh, core knowledge that we are actually trying to achieve, that coding part is not the important, because you can get the code online. Okay, you can look up reddit you can look up reddit, geeks for geeks, Stack Overflow, Stack Exchange, anything, anywhere. Also, the official documentation for that instance, and you can get the code. But if you don't grasp the very idea of writing that particular code, then it is a little bit of problem for you. So I'll be revisiting everything. So don't you worry. So it is better that we stop tomorrow or start today, and we have ended our machine learning project journey. That is the ML ticket. We have, as you have bought the ML ticket and you have reached the final destination, and before the train pulls up in the final station and you start unboarding the train, we want you to, I want to go through that entire journey one more time, so that it's a wonderful feeling, right? So you can sign off, and of course, if you, as you know, if you have any questions, just ask me. And later, if you have any questions while doing the code, you can just drop it in the WhatsApp group, and I'll be answering it as soon as possible. Okay, so enjoy the rest of your evening. Goodbye.